Hi, Gadget UK here again. Third part of the consolisation of my MV1FZ. We've got the fuse, 20mm fuse holder here. You should put a fuse in this. It's pretty dangerous. Well, not really dangerous, but risky towards the life of the console. Ultimately, really, unless you protect it by a fuse. If anything starts to go wrong with the main board, at some point it starts to draw a little bit too much current. Half an amp too much or something. You're going to regret it if you don't put a fuse in there. So I need to do some work later with a meter to work out exactly how much current this thing's consuming on the different carts I've got here. So I'll do that later. Main switch. So as you can see, I've got the hole there for the power connector. And you can see that. I think I'm quite new to the measurements of these. The power supply I got was marked or described as, I think it needed to connect to this 2.5 by 5.5, so I went away and found one of those, a socket, and it's exactly right. I've tried that, plugs it in, it's fine, and it's held in place with a little, so I just need to just mount that in there now, cut out a little slot, power switch, mount that there, obviously wire it in such a way that it goes through the fuse. Then we should be good to go. The final steps on this really is to wire in the controller ports, and the other thing I'm going to do is mount some of these little, you can see, little tactile switches. They've got 6mm notches on them. I'll just take one of these out and show you what I'm going to do with it. Right, yeah, I'm going to fit 4 of these. And because they protrude a little bit, by the time I've stuck them on a little bit of Veristrip board and put them, cut holes, they'll just protrude enough by about 1mm or so, just you click, be able to press them. I'm going to have player 1 coin on one side, player 2 coin on the other side, reset on one side, what was I going to have the fourth one for, and the test button on the other side, so there'll be 4 of these. I might put the 2 coin ones on the same side and have the test and reset on the other side, I don't know. Might make sense actually. I might put the coin 1 and coin 2 next to the game ports on that side, and then put the reset at the front here and have the test switch on the back there. I'm not sure I'll ever use them, but I guess I may as well do it while I'm there, and it should look alright. So anyway, I'll just finish fitting this and start wiring it up. Right, I've cut a hole there for the switch. It fits perfectly. I've had to flatten the contacts on these just because of the way I've got this acrylic in there. I don't want to cut a piece of that acrylic out, but that fits. As long as I solder onto the insides of those tabs, it'll fit nicely in there. Tested that, it fits perfectly. So the next thing to do is to solder the fuse onto the sensor pin. So it's going through the power will go through the fuse and then back into the switch and out from the switch to the board. There you go, you can see that mounted now. So I've got the fuse holder inside there, power switch and power connector. So I've tested that works. There's no sound. I didn't realise I would need the plus 12. I thought that was only if you were using the mono amplifier. Yeah, so I'll have to do the plus 12 volt mod. It shouldn't take me long, but I'll do that later. Adjust the time. Some of that's background noise, as you can see. Yeah, I mean that's set to I think 5 millivolt per division. So there's definitely some noise giving out that power supply. It's not a totally smooth signal. I think I'll put a cap on there. Just on a quick check here to see what current this is using, and you can see that 1.3 amps there, sort of sat with the menu sort of on with a multi-cart. So yeah, the current consumption's pretty low. It's nowhere near the 7 amp that SNK quote for the MV1FZ. And this is bearing in mind that I've also done the 12 volt mod in here now, so the sound is also routed through the plus 5 as well. It's just all powered off of plus 5. I got an 8 amp power supply, currently got a 3.15 amp fuse, but I think I might put a 2. amp fuse in there because it's not even using 1.5 amps. which is more or less what I expected really, because there's not anything really particularly beefy on there. You know, I mean, you've got that's probably using more power than many of the components on there. The audio amp, I'm not even using that, but still, it'll still be consuming a bit of power. So what I thought I'd do is just start a game up, and we'll see how much power that uses. Let's find Metal Slug. There we go. Metal Slug 1.
Metal Slug. This shit. Start.
So as you can see, it's pretty constant really. If you're going to do this yourself, you can get away with I would say certainly a 3 amp 5 volt. That's all you need. It's more than enough. It's 100% more than what's more than 100% more than what's required. So anyway, at least I've ruled that out. So I'll get a 2 amp fuse put in there and put it back together. So for the controller ports, I've used an old IDE cable, chopped it up. You need I think 12. There are 13 pins used, but one of them goes to the same cable. I think it's a D button goes to 2 pins. I think it's one of these pins. I've not yet got a jumper on here yet, so I'll stick a jumper to one of the pins on the other side, which is button D, I think it is. Yeah, so you need 12 strand wire effectively. That's okay, and the way I've done this is I think pin 1 is that pin there, so I'm just going to you missed pin 2, so 1 all the way through to I think it's 8, and then I've continued on with the next strand going on to starting on pin well, that would be pin 9, so you skip 9. I think 10 is used for the D button, so it'd be pin 11. So there's just sequential, so when I come to wire this up, I can just look at the table and I can go, okay, 1, 2, 3 all the way to 12 or whatever, and it should be straightforward to do. So I'm just going to do the same thing with the other cable now. For the second port, I've tinned the ends here. I'll just fill the relevant pins here with a bit of solder in preparation, and then join it all up. Now, I don't know whether you're going to be able to tell, you probably will, the way this video's probably been put together, varying light changes and stuff. I've done this over several days now, just in bits and pieces here and there where I've had sort of half an hour to spare. You can see there, I finished reassembling pretty much. It needs a tidy up, you know, the sound mod there needs taping down or gluing or something. I need a bit more glue at various points in here because I had to remove some of the glue in the corner points because of the connectors. But yeah, it's all working, aside from one thing that I spotted when I did the controller. Right, so I've got controller 1 plugged in, so go into the test mode. We've got left, right, up, down, A, B, C, D, that's all correct. Select start, obviously goes through the test mode again, so that's working. I'll go back round again, and we'll just plug controller 2 in. Right, so controller 2 is now plugged in, and we got left, right, up, down. Just going to check that again, down, yeah, that's right. A, B, C, D, select, start. Start. As you can see, start is not working. Now, what's interesting about this is, if you remember a few videos back, when I can't remember when it was now, when I was doing some other mods to this, or maybe even the repair, I experienced this really weird scenario. Certainly went before I did the repair, where player 2 was automatically starting, and I was convinced at the time it was something to the backup RAM. But after I did the backup RAM repair, the problem went away, you know, and I assumed everything was working fine. I'd never actually used the second controller port or even tested it, so anything could have happened to it in between that, you know, that point. Then I did the repair to the backup RAM. Obviously replaced the 74 HC32. Everything was working fine. Started doing this modification for the case and everything, you know, wiring up the video and stuff and the power. And then at some point during that, when I was testing, it started playing up again, where player 2 would start automatically starting as if someone had held the start button down, which was very odd. You know, this has happened a second time. You know, previously I had attributed it to the backup RAM problem, but this time apparently not. What I've done is, using the logic probe. It's not connected to anything, but yeah, using this logic probe again, I've traced the inputs from underneath the board. I think it's one of these end ones here. These ends, it comes in into one of these little RFI things, whatever they are, what they called, it's like a bead, isn't it? Ferrite bead or something. It goes through one of those into one of these, which I thought were just resistor packs. I think, in retrospect, from looking at the schematics, these are capacitor resistor packs. So you've got a resistor network in there with a couple of capacitors in there as well. Anyway, so they go through these. Under the board, it comes up through a couple of, I forgot where it goes now. I think it goes along the surface here actually, up to about there. You see the tip of where that, I don't know if you can see it, the tip of where there's like a little corner point there, sticks out. There's a via just below that. Well, this player 2 start goes through that via, under the board, comes back up, somewhere here through one of these vias and goes to one of the pins there. I think it's pin 71. And I've traced that with a logic probe initially, and initially it's high, as it should be, as all the other inputs are, and it goes low as you press the start button, and I've tested that, and that works. So the signal is hitting pin 71 of the Neo C1 chip here, and then after a little bit of research and posting a few questions on the Neo Geo forum, I've determined, a few people helped me determine that one of the output pins here go to D10 on the CPU, and it's that particular bit is what passes the start button effectively when it's addressing a particular address. I think the address is 38,000 H. So when the CPU addresses 38,000 and presumably passes some sort of control signal to this, I don't know what that is yet. I'm not familiar with 68,000s in terms of how they assert different chips and things, and you've got UDS and LDS and AS. I'm not sure whether one of those or combination, or even some of the pins that I've not even looked at yet, may well be used, but bottom line is it sets the address, does some sort of assertion, and then reads the data pins of the upper part there from is it D8 or D9 onwards, and it just happens that D10, like I say, is the bit that holds the state for the start button. So you would think, my initial thoughts were, okay, maybe the connection from the C1 chip here to the CPU on D10 is broken or noisy or something, but that's not the case, because depending, let's say, come back to the whole addressing thing, it addresses on 38,000H, 38,000H, in order to read specific set of bits, and those bits are the select buttons and start buttons. But it will address a different address, say 34,000H, if it wants to get the left, right, player 1, or I think 30,000H if it wants to do the other player, left, right, up, down, all that sort of stuff. So you can see the problem there, that it's all going across. As far as I'm concerned, there's one D10, one output from here to D10, and depending on how it's addressed, it will output a specific bit. In each of those 3 different scenarios for the 3 different address ranges. So that sort of breaks the theory that the D10 line is at fault and points towards the internals of C1 being at fault here. Something's gone wrong. A transistor's failed, or a resistor's gone open circuit. So I'm looking at a faulty C1, which is not good news at all. It's not what I wanted. It's not what anyone would want. Stupid thing to say, but you know what I mean. It's shit. It's pretty shit news. So there's a few things. I could look for a second board and replace C1, but to be honest, I don't want to spend the money. I doubt I'm going to find that. They're hard to find, these boards, as they are anyway. I've been watching eBay for a few weeks now, and I haven't seen an MV1 I've said come up at all, faulty or otherwise. And then there's the fact that there are a few. I've got a bit of history with this board now. Obviously, I've replaced a few things on it. It's got those sockets, the components socketed there. It runs in every other aspect. It's faultless, aside from the fact that you've got this one problem with the start button on the player 2 port not working. So what I'm going to do with this is approach this from another, unorthodox angle again, of actually fixing the issue with a little patch board. what I mean by that is I'm going to get some Veristrip board, a matrix board, and I'm going to put on it a couple of. I need to sit down and do the logistics of this, just to get the finer details to work it out. But what I'm going to do is get a piece of Veristrip board, stick a couple of AND chips on there, AND gates. If you watch if you watch the video where I repaired this, I described a little bit in detail about how the OR gate is used there and how those work. And now. How I replaced that. But what I'm going to do is stick these AND gates on a PCB and feed into them the address lines that the CPU is using to address this. Now when I look at the schematics, I believe there are something like 5 or 6, I can't remember, there might even be 7 address lines. There's not very many, there's certainly 4 that form the identification part of the address, that sort of 38,000, 34,000, 30,000 address. It's the uppermost 4 significant bits of those addresses are used, as far as I can see. So I might be lucky, I might be able to reduce those 4 bits to identify whether it's trying to address the controller inputs, and more specifically, the controller inputs for the select and start buttons, that 38,000 address. If we can do that with some AND chips, and I might, let's say, coming back to the whole, there's 4, but when I look at these schematics, I think there's something like 7 address lines go there. There are 3 others that go to other pins on this chip. I may or may not need those. I honestly don't know yet, unless anybody helps me clarify that on the Neo Geo forums, but certainly with 4 it will work, with 7 it will work. It just means more AND gates. But if I feed the inputs of these ANDs all together, I'll have to, for example, I'll take 2 address pins. You get an output of that, 2 more address pins, an output of that, 2 more address pins, an output of that, 2 more address pins, an output of that. So I've got 4 lots, if you like, with 4 outputs. Feed those outputs into another AND gate, join those together. So eventually I've got 1 output, and if I AND that with the inverse using a NOR gate of the signal. So what I'm saying is, the way this works is it's a high. The input is a high, and then you press the button and it goes to a low. Well, I think I'm probably going to need to invert that. So when the CPU reads D10, it's expecting the bit to be set. It's expecting a high as a button press rather than a low. That's just speculation at this stage. But so if I NOR the input through a NOR gate, so it invert an OR gate. You've got one or the other input will give you an output. With an OR gate, if you put a high into either of the inputs, it'll give you a high as an output. But with a NOR gate, if you put a high into either of the inputs, it will give you a low. And if neither of the inputs are high, it'll give you a high. So the idea is to invert the input coming in here, and it with what I mentioned earlier, the address logic there, and in all of the address lines together. Bear in mind, I'm going to have to invert one of those address pins, because it needs to be a low. The 38,000 address range, I think it might be the third from the top bits, that is, not from the bottom, needs to be a 0. So I need to make sure you get that logic there with the AND logic on the addressing correct for that specific address line. But in theory, I should then be able to, I'll have a condition where when it's addressing the C1, it will automatically be ANDing the outputs of the start button, whether it's a high or a low, through to D10. And I'm probably going to need to expand the criteria there a little bit. I'm going to, as I mentioned earlier on, I might have to use some sort of assertion type pin or whatever it is on here that between these two that the CPU uses to indicate, via a high or a low to C1. Say, hang on a minute, I'm trying to assert you here, I'm going to read from you. Give me exclusive access, to stop whatever else is, you don't want other things reading and writing at the same time on the bus. So there must be something there. I don't know what that is. That's what I need to identify. And when I can do, once I've done that, like I say, I'll end up with a little breadboard, little piece of Veristrip board, a matrix board. It's probably going to have 2 AND chips on there, and a NOR gate on there as well. So it's it's not going to be a huge thing, but when you look at it, it's going to be significantly larger than the C1 chip. but that should, in my mind, I can't see anything wrong with that approach. That should solve the problem. It's not going to be elegant, but it fixes it. It means that I can continue to use this. All the other functionality on here works fine, and there's no telling what may happen with that chip in the future. But to be honest, I've used this a fair bit, and I suspect, and it's been fine, and I suspect that it's been playing up since I got it, that pin, and it may well start springing back into life again. I honestly don't know. Yeah, I mean, I've had the scope on it as well, that you can see here. I mean, I can try and show you. If I connect scope to that point there, you can see it. So this is the point. This is the via. I don't know if it's going to come out very clear on there. It's not. You can see that dot's moving up and down there. I may not have the scope set to the right setting. I don't know. It's on DC at the moment, and you just get a dot. You don't get a line. Appreciate if anyone can correct me whether I'm using that wrong or not. It's a long time since I've done any of this stuff. So you can see it's going from a low to a high as I touch it, and as I press the button, it will drop accordingly as well. And you can do the same thing tracing to, I think it's pin 71 on there. You see the same pattern, that as you hold it there and press stop and start, hold down and the start button and release it, you can see it going from a high to a low every time you press it. As you hold it down, it's low. As you release it, it goes high. And I've put the scope in. I did switch the scope into AC mode early on, just to look at some of the inputs there, just to see if there's any shit on the lines, really, any noise. And they're identical. It's funny the way that these vias are laid out here. I think the pin I was dealing with was that one there, that via. That's the start button. I think the one next to it, not the one near the top there, but the one sort of almost right next to it over that one trace, that's the select button. And just probing each of these with the scope and just looking at both the DC and AC settings, you can see the DC levels are right. It drops to the right amount when you press the button, and there's certainly no noise on any of them. And the other thing, just to rule things out as well, is I've shorted, using the probe actually, the two pins on here that all of the pins down this side here, just near this side here, usually are all inputs and things, so you can't go too wrong really. You've got to be careful because there are some control signals and voltages and things on here. You don't want to be shorting +5 or ground to anything. Well, ground might be alright, but +5 you don't want to be shorting that anywhere really. But yeah, so I shorted a couple of pins together here. The start and select are right next to each other. You can see, as you've got it on the scope or the logic probe there, as you press select, you can see the select one. You move the pin across, you do the start, nothing. And if you short those two pins together and press say start, the start will simulate, if you like, or force the select signal. So as you're watching the screen here and you're pressing the start button, the select signal will light because you've joined the start and the select pins on that chip, which to me says, the inputs that's coming through here, it's correct. The voltage levels are right. It's it's dropping it to the ground level or whatever correctly. There's no noise on there or anything like that. It is purely, something within C1 has gone open circuit effectively, or it's a similar sort of failure there. Bloody annoying, but anyway, I'll finish putting this all back together after I've fixed that. But I think I'll probably upload a video as this is now. It doesn't look particularly amazing as it is, but let's say the keys here in terms of this particular video is identify the fault, identify the particular resolution as unorthodox as it is, or I should say as it might be. Power connector done. Power switch, 20mm fuse. Coming back to this problem with C1, before I forget, before I just end this video, I could have done this. This could have inadvertently been done by me. It could have been a fleck of solder somewhere, because I have found the odd one while I've been working on this, this week, and I've been like, God, where did that solder come from? There's one across a couple of traces under the board and stuff. Similar to what these vias here. One of them could have put 5 volts straight through, that particular pin. And reading on the forums, people have suggested that sometimes what happens is people put the jammer upside down and end up putting voltage onto some of the other pins. But I've looked at the pinouts for this, and I can't see how that would be possible, to be fair, because the way that I forget which pins it is now for the select and start buttons for P2, but they are in such a position on the board that even if you flipped it over, there are no voltages. You connect it to like the red, green or blue or something if you flip it the other way. and it doesn't matter, you know, which orientation you have that. I can't see how you can. And the other thing I looked at here was if the board was at an angle. You know, if you didn't have that, if the connector, you just slide it off and it wasn't, you know, wasn't straight, and you had a couple of, you know, shorter to the pin next to it. Would that have caused the fault? And I can't see how that would do either, because again, you've just got other inputs next to it on either end of it. It's not like you could, you know, inadvertently put in the plus 12. You know, because it's not like a neighbouring pin; it's right across the other side the connector there. But you know, there was when I did this mod, as you saw, and I covered this briefly in the sort of what's it called, annotations and things in the last video. Is when you work on one of these boards, you should have an anti-static wrist strap on. You know, was that it? I doubt it. I seriously doubt that it's because it didn't have an anti-static wrist strap on. But it's a possibility. Having said that, it started playing up intermittently at a time when I wasn't doing any work on it, so I don't know, it's one of those. And the other thing that was more significant in my mind was the fact that I left the battery on here. So I had 3.6, 3.7 volts, or however many volts that's holding charge. I mean, it's rated 3, but it'll hold up to like 3.5, 3.6 or something when it's charged. And I did the work on these SRAMs, and if you think about it, these SRAMs, you've got address lines and you've got data pins. Well, let's for argument's sake say when I was desoldering or resoldering one of these, you know, certainly when I desoldered, you know, I did the flood fill soldering technique there. Well, you know, you're going to have +5 to quite a lot of the pins for a few seconds, for a minute or two while I remove the chip. It's possible that the +5, not really +5, but 3 point whatever volts has gone through into one of the into the data pin, and other chips have been okay with that. This chip has taken offence to having, you know, a few volts, 3 volts into that pin. I doubt it. I seriously doubt it, but it's a possibility. It really is a possibility. So when you're doing any work on these, do remove the battery, and you know, be careful with your soldering. Make sure you don't get any splashes of solder anywhere. And I would say that it's probably worth having a really good inspection of the board after you've done any work. You know, with a magnifying glass and stuff. Up close on both sides, not just where in the area you've done the work, but perhaps outside of the area, just the whole general board, you know, the general area, or the whole board really, just to make sure that you've not got any, you know, unwanted visitors really, you know, little bits of solder that could be shorting things out. I don't think that's the case. I don't think that's what's happened with this. I think when I think back to, you know, how this has behaved from the minute I got it, you know, I had the backup RAM issues, but player 2 was starting on its own, and that has been a key thing with this that I've noticed. You know, it's happened more than one occasion. It happened when it was rebooting itself. You know, and it kept rebooting. It's that same thing. It was rebooting, but if I managed to start something, players 2 has started. Yeah, I think that chip's been playing up since I got it. I hopefully it won't fail in any other kind of way, but you know, only time will tell. Well, there you go, you can see it's all assembled now. I'm going to fit a new C1 chip, a Neo C1 chip, because it's a lot of effort really to try and use some AND logic, and I got some feedback on the Neo Geo forums, and it's going to be more complicated. I had concerns about timing issues are going to be very difficult, because if you imagine, you know, the CPU's running at 12 megahertz, so a typical cycle, you know, an instruction, the time it would take to operate a particular instruction or whatever, you know, the number of cycles is pretty low. You're dealing with the nanosecond range. I'll just switch this on. So you can see there, I've got the power switch. There's a 2 amp fuse in there. I've measured this as I showed earlier. It's 1.3 amp it consumes, so that's fine. And I've got my game port just on the side there, and the 8-pin U. Same as the AES, so it's all working. Find something to start. As I was saying, yeah, so the CPU's running in the, all the cycles are in the nanosecond range, and the propagation times for the AND gates and things, and the NOR gates that I ordered for the to try and fix that C1, you know, the player 2 start input, are in the microsecond range. You know, it's a factor of 1,000 out or something. So, you know, there are too many problems with delays and things. So I posted on Neo Geo forum. I think someone's going to hopefully sell me either a Neo C1 chip or a faulty board, and I'll have to swap out the Neo C1. Anyway, thanks for watching. Hope you found this interesting, and see you soon.